Okay, yesterday we would graph these in shade, and now we're going to take the corners. I mentioned that the corners are important, and I'm going to show you how to solve for those corners, to find exactly where those corners are, so that we can optimize the scenario. Whew, that's heavy-duty stuff. All right, would you please get to this page right here? Do you get that I have 3 lines, and I could use some sort of math to figure out where these 2 lines cross? Well, graphing is pretty easy. I mean, I can look at this and say, where are they touching? What's that point? What comma what? What is it? What comma what? 2 comma 3. That means x is 2 and y is 3. X equals 2, y equals 3. This one, again, I can see on the graph where it touches right there. That's what comma what? 4 comma 0. X is 4, y is 0. So at this spot, I would have 2 x's. I don't know what they are. Maybe this is about, x might be about dogs at the animal shelter, and y might be about cats. And then this would mean I had 2 dogs and 3 cats in this scenario. This spot is not so nice on the graph. Do you get it? I can't really tell exactly where that spot is. So that's a good example of how we would need to use some different kind of math than just looking at my graph to figure out this spot right here. Give me some options. The green equation is this. The blue equation is this. Give me some options on how I could figure out exactly where that spot is. Say this is the ACT, and the question is just, where do those 2 lines cross? Well, give me some options. Yes? You could absolutely use substitution thing. Tell me what the substitution thing is again. Put the one equation into the other. Okay, so I'll pick one, a green one or the blue one. Which one do you want to put into which one? It doesn't matter. You can pick either one. All right, so here's the green one. Y equals all that. So where do I put all that? Where? In the y, because y equals all that. Would everybody please, off to the side of your paper, write this. 3/4 x minus 3 is equal to negative 1/2 x plus 4. Then option A is we solve that equation. It's just an equation, which we can solve with algebra. I've tried to train you that whenever you see a fraction in an equation, you should get rid of it. Now this one's kind of weird because there's a 2 and a 4, and I've always said multiply by both. But in this case, I don't have to multiply everything by 8. What could I multiply everything by that would fix both of them at the same time? Yes? 4. Multiplying by 4 everywhere would fix this, because see, the 4 multiplying here will just make this cancel. 4 and the 4 will cancel. Multiplying by 4 here is necessary. You have to multiply everything by 4, right? I'm going to multiply by 2 times 2 here. It's the same thing as 4, isn't it? And it allows me to cancel this 2 and multiply by 4 here. Everything got multiplied by 4. It's just that I chose to use 2 times 2 right there. Would you please write down what results after I multiplied everything by 4? (3x minus 12) is equal to, those 2's canceled, negative 2x plus 16. Does that seem like something you could solve from there? It's not too hard. It's got x's on both sides. Go ahead, finish it up. I'm going to pause for a second while you solve for x. And when you're done, by the way, and you get x equals 2 or whatever it is, granted, it's not going to be a nice number because look, these lines are not crossing at a very nice spot. It might be like x equals 2 1/3. In fact, it probably is. It's 5 point something. I can tell because of where this is. X is probably 5 point something. I'm going to pause for a second when we solve that. Okay, so I'm adding 2x to both sides. And now I have 5x minus 12 is equal to 16. Now I'm adding 12 to both sides. 5x equals 28. X is equal to 28 over 5, which is, by the way, 5 and, I knew it was going to be 5 and something, right? 5 fifths would be 25, so there's 3 left over. 5 and 3 fifths, also known as 5.6. That's the algebra way to do it. Is there another way to do it? Remember me telling you at the beginning of the hour to take out your graphing calculator? Everybody grab your graphing calculator. And I'd like you're going to get 5.6 again. But the nice part is you won't even have to go back and solve for y. Like right now, I'd have to use 5.6 and go stick it in one of these two equations. X is 5.6 has to go into one of them and to figure out what y is. But by using our calculator, we'll get both x and y at the same time. So grab your calculator, and if you're already ahead of me and you're ready, type in that as one of your equations. And yes, you can use negative 0.5. That's a lot easier to put in than negative a half with parentheses. Okay? And then that's the blue one, and this is the green one, is 3/4 x. What's simpler to type in your calculator? 0.75x minus 3. I'll pause so we get that in your calculator. So I guarantee you there's some kid who just went in their calculator and they're like, what the heck, my y equals screen is all messed up. Just a reminder, you want to be in mode and then under function. So if you are in a weird mode so you can't see y equals, go into function mode, then go back to y equals, and there we go. Okay, now in my y equals line there, I'm going to type my blue one first, negative 1/2 x, so negative 0.5x plus 4. Now, if you hit a minus key instead of a negative key on that 1/2, it won't graph. So why don't you just check and see if it graphs just right off the bat. And again, if you're in some weird mode like I am, where I can't see the normal graph, Zoom 6 gives you the best results really quick. Zoom 6 just snaps you back to like the standard window. I do want you to remember how to set that window, but it's kind of complicated. So Zoom 6 kind of resets it to normal. Okay, now, can I see where the other line crosses that? Sure, as soon as I type it in. I go to y equals, and now I'm going to type in this green one. Y equals 3/4, also known as 0.75 x minus 3. Oh, nuts, I just typed it over the other one. I'm going to put this one back in here. Sorry, negative 0.5 x, what's that again, plus 4. There, now I got both equations in. I'm going to hit graph, and I'm going to see where they cross. There's one. There's the other. And let's see where they cross. Do you guys remember where all those cool, like, ways to calculate things are? Second, and then under, it's, second means above what key? Above the trace key. So second, and it's calculate, which is above trace. Get in there, quickly. Then, which of those choices is it? Number 5, intersect. Now, some of you might be thinking, okay, I'm just going to always do it with algebra. You are not going to want to always do it with algebra. What if the answers have really, really icky long decimals? Do you get what I'm saying? The calculator is going to be pretty handy for that. This is a really good way to do it. So please follow along. Just type in your two equations and then hit second calculate intersect. And my advice on this, it's going to ask you questions down here. It says first curve, you know, right here. So my advice to you is to get really close to where they intersect. And if you only graph two equations, that's the key here. If you only graph two equations, then the answer to their three questions will just be hit enter, enter, enter. Because it'll be saying, am I on the first curve? Yes. Am I on the second curve? Yes. And I wish they just called them lines because, you know, they're straight lines in this case. They're not curves. And lastly, it's guess, and I just hit enter again. That just means I'm pretty close. There we go. Remember how I said it's 5.6? But what's better about this? I got the 5.6, and I also got The 1.2, the y. See what I'm saying? That's pretty handy. So, do you remember me telling you that a great way to solve equations is to graph both sides and see where they cross? Think of it this way. Since y equals this and y equals that, then the real equation we had was negative 1/2 x plus 4 was equal to that, because the y's are equal to each other, right? And how do we solve that? You graphed both sides and we saw where they crossed. So what was the final answer? 5.6, this one, and y was equal to 1.2. How do I know that? Because it said so right there. Okay, why do we care so much about these points? Because in the answers to your next test, the answers will always be the corners of your little shape. The shape is called the feasible region. So that's why we care so much, because these spots, one of these three spots is your answer, and we don't always make them nice spots. Like this one was easy. This spot was just 2, 3. Sometimes they're icky, like this one. It was again 5.6, 1.2. All right. Let's look at this was the one where I said use algebra. That's the one where we multiplied the whole thing by 4 to clear the fraction, and we solved it kind of the long way with algebra. Then I do like this way with the calculator, as long as you know how to type it in and hit second calculate, that's right above the trace key, intersect. That'll be critical. All right, so let's just make sure you really have that down. Would you, I know the answer is 4, 0, but would you please type in those equations and hit second calculate intersect, and when you're done, your calculator will be on that spot and it'll say 4, 0. And I want to see that on your calculator. So I'm going to ask you to show it to the kid next to you. I'm going to pair you in rows 1 and 2. The person across from you, you're going to show them your calculator. Because I know there's a few kids hiding right now that don't know how to do this. We need them to get like out in the open and say, show me how to do this, because I don't get it. Okay? Put in the two equations that would find this spot, and then show the kid next to you that you can do this. You'll show them, I'm on it. See, this says intersection, and there's my 2 spots. If you and them have the same answer, then you both know how to do it. By the way, if you're having trouble typing in the red one, I would use negative, what is 3/2? Negative 1.5. I'm going to pause for a second. I want you to see theirs. Don't just show one way. One person shows it, only shows me that one of the two of you knows how to do it. I'm going to pause while you show the other person. Okay. I know that there's always going to be 1 or 2 holdouts that just can't figure this out. But come up and talk to me one-on-one, and I'll show you how to make it work on your calculator. Maybe your calculator's in messed up mode or whatever. But did you get 4 for x and y was equal to 0? Did you get that to come up as the intersection of those 2 spots? How many of you were successful? You got your calculator to work. Okay, awesome. If you weren't, please come up and ask, because you're going to need to know that for your next test. All right, so I'm going to kind of gloss over this pretty quick. If we asked you to graph these, you would get 4 lines, and they would probably all converge like something like that, and I get a shape on the inside. What would be the important spots? The vertices, the corners, okay? I'm going to trust that you know how to do that, how to find those corners, because I need to move on to the next part, which is once you have those 4 corners, what do you do with them? All right. So if I was going to use those corners, you have to do something called optimizing. So we're going to go to this problem, and I got to show you this concept of optimizing and also of writing the equations. Okay, first of all, it tells me something really important. You have to decide ahead of time in a problem like this what it's about and what you're going to make x and y. Okay, it tells me right here it's going to make x be bagels. If that hadn't said that, you could have picked bagels to be x or y. You get to pick. In this problem, it's picked for us that X is going to be bagels. So I want you down here to write bagels. And then Y is muffins, so right over here, muff. All right. Then the constraints are the equations that you have to write about that. Like, what if they had just said, you are going to sell 10 muffins? Well, when muffins is Y, you'd say Y equals 10. It'd be that simple. You are going to sell 6 bagels. Well, then X would equal 6. Their equations aren't that simple, of course. But constraints are just equations that have X and Y in them. So this is the real one where you separate the people that can really problem solve from the people that can only like solve an equation that's simple. And this test will kick some of your butts because you won't try hard during this next few days. Because this is a short unit and we have a test near the end of this week. It's either, I'm not going to tell you the exact date because it might be different in other people's classes, but in just a few days we're having a test on this. So try hard, pay attention here. Will has been sent to the grocery store to purchase bagels and muffins. Cool, we've established that. He can spend at most $28. That means with his X's and his Y's together, it will be at most, that means less than or equal to 28. Can I write an equation for that yet? Yeah. His X is packages of bagels and Y is packages of muffins. But if I write this, this is really, really important. Listen to this. I have just said his number of packages of bagels plus his number of packages of muffins must be less than 28. Is that what it says? No. It says the money we spent must be less than or equal to 28. So that's not right. We need the cost of the package of, what are the X's again? Bagels. And we need the cost of the packages of muffins to be less than or equal to 28. So do you get what I need to do? I need to put a number in front of each of those. So how much does, this is how many packages of bagels I have. How much do the bagels cost? Just reading the question, where does it say? Package of bagels costs $2.50. So you put 2.5 right there. This is what you do on your paper right now. Some of you didn't move your hand. Okay, now, how about the cost of the muffins? I bet you can figure out where to put that. The muffins are the Y. Package of muffins costs $3.50, so you put the 3.5 right here. Now, this is turned into, this is how much money times this is how many packages. Money times packages has to be less than or equal to money. That actually will work. That's a complex equation. It's not impossible. In fact, usually our equations are going to follow this mode, where there's a cost for each item. So you'll have your little cost in front, and then you'll have how many of them you have. And then you'll have the cost of the next kind, and then how many you have. And then the total has to be less than a certain amount of money. Because, like, you go to the store, and nobody says, you have to spend at least $50. No, they usually say, like, all I have is $100, so you better spend less than or equal to 100. So it's almost always a less than or equal to right here. All right, all of that got us one of our equations. And that equation right there is one of the constraints. That's a Y. And that's an X. There we go. Is there more? Yes. I'm going to just underline it. I'm going to ask you to try to figure out what the equation should be for this black underline. He needs to buy at least 2 packages of bagels and 3 packages of muffins. Hint, make them separate equations. There's 2 equations there. He needs to buy at least 2 packages of bagels and 3 packages of muffins. One of those equations is about X, one's about Y. I'm going to pause where you take just a few seconds to figure out how to say at least 2 packages of bagels and at least 3 packages of muffins. Okay, which one was bagels again? Oh, it was X. I could see a kid thinking we should use 2.5x, but that's going to bring in the cost of the bagels. We don't need that. We just need to buy at least 2 packages of bagels. So x needs to be at least greater than or equal to 2. Raise your hand if you had that one right. Yay, there's hope for you on writing equations. And then the y is the muffin, so y needs to be greater than or equal to 3. Now, do you think that the lines up there on our graph are up there randomly? Look at where they are. Do you see the red line is that x equals 2? Do you see the blue lines at y equals 3? See what I'm saying? They've already got the lines in the right place for us because they know that this lesson takes a long time. So what does it mean to be above, sorry, I just said it, greater than 2? It means above or to the right of 2. So I'm going to do a little bit of shading here. See how I got a shade to the right of that line? For this equation, I got to be less than or below 3. So that's this one here. Needs to be below this. I was thinking it was going to be right in this zone, but it's not. Because, oh, wait a minute. No, it is going to be, no, my bad. Sorry, it says greater than 3. Oops. Greater than 3 means above 3. There we go. It is going to be in that little triangle. And last but not least, this whole thing, which if you take the time to graph it would be that green line, it needs to stay less than 28. So less than means under, so it goes just like that. And then, of course, that little triangle did become our feasible region. Now, this spot's really easy to find. It's just what comma what? 2 comma 3. That spot right there, not quite as easy to find. This spot here, again, I can see it. It's right on the graph. That's 7 comma 3 right there. That spot, 7 comma 3. But this spot's the one that's a pain in the butt. I can't tell what it is. What do I do? This is the one on the test where we really separate out the kids that get the A's. They're the ones that know how to find that weird spot. Yes? Take the 2 equations, the green one and the red one, and then, yes, absolutely can do that, but there's an even easier way this time. I know I love the equation in the calculator way, but there's an easier way. What is the equation of the red line? It's 2. What's 2? X is 2 or Y is 2? Nope. X is 2. That's an equation. X is 2. The line itself is X is 2. Now you could say it's greater than 2, but that's the shading to the right. The red line is X is 2. And the green equation's right here. If I know X is 2, can I just substitute it right in here? Bloop. Plop it in right for the X? Yeah. In this case, it's faster than graphing both equations and seeing where they cross. Especially because, have you ever seen on your calculator a spot to put X equals things to graph them? Isn't the button called Y equals? You know what I'm saying? So if I say, oh, go graph it on your calculator, people will be like, where am I supposed to graph X equals 2? All you can do is draw a line in there. That's not an easy thing to do with your calculator. But with substitution, we can stick the 2 into here, and there's going to be a 2 right there now. And I can do that in my head. 2.5 times 2 is 5. 5 plus, I'm just reading this equation now, 3.5y is less than or equal to 28, and I'm going to solve it with algebra. So I'm going to subtract 5 from both sides, and I'm going to get 3.5y is less than or equal to 28 minus 5, which is 23. And then I'm going to divide by 3.5. And then there's my answer. There's no reason I can't grab my calculator now and get that decimal at least. Okay. I think you guys have stolen all my calculators that actually work, so somebody else is going to have to do this one. 6.5 what? Could anybody verify 6.6 approximately? All right, thank you. So, I have found this spot. The x of it I already knew because it was that red line. So x was 2 and y was 6.6. All right, Now, how do we optimize? This is an intense lesson because we got to even do optimizing. All right. Imagine for a moment, they've told us how much it costs to make a bagel. Do you get that the reason they make the bagels is because they make money? Think about that for a second. Why do they sell bagels? Because it doesn't cost them that much to make them, and you buy them and they make money. Okay? Let's just for your guessing's sake here. How much do you think they make on a bagel versus the cost of actually making the bagel? You know this? Did you like look it up, or are you just... Okay, it's just a guess. All right. All right, let's say it's $1. Because I want to have a nice easy number. Let's say it's $1 profit for a bagel. The things that cost more money, the Y's there, the muffins, would you assume then if they cost more money, they maybe make more money too? Okay, can't always assume that, but let's assume that for just for the moment. Well, let's say that you make $2 profit on the muffins. These are packs of muffins, but anyway. Then how can you tell which of these spots the company will make the most money on? Remember, I told you it's going to be either this spot, or this spot. How can you tell where they're going to make the most money? Because at this spot, it's 7, 3. They're going to get 7 X's, which were the bagels, which is $7 of profit on the bagels, plus $3 of profit on the muffins. Sorry, three sets of muffins, of which they will make $2 each. And so you make this profit equation. It's called an optimizing equation. And that equation would look like this. I get $1 for each X. This is profit equals. Plus I get $2 for each Y. And then I stick in my points. These points here, the corners. That corner, which we know is 2, 6.6. That corner, which is 7, 3. And that corner, which is 2, 3. And I see which one gets me the most profit. This one, 7, 3, is my... No, wait. I think it's probably going to be this one. Why do you think this one might be better than this one? Where do we make more profit? On the Y's. This one's got more Y's. That's why I think it might be better. All right, so here's the final. I just need to show you the completion of this one problem here. I'm going to scroll up a little bit. So here's the final thing you have to do. You got your profit equation. They'll give you that or tell you how to make it by telling you, here's how much profit we make for this and that. And then you make each point. What were our points? One of them was 2, 3. And then I say, I'm going to put that in the equation, and it gives me this much profit. Then the next point I have to check was, help me out, what was another point? 7, 3. And last, what was the last point? 2, 6.6. Thank you. Everybody write those down, just like I'm doing. Those are the corners. I showed you how to find the corners with the calculator or with algebra. Either one's fine. Once you got the corners, you take those corners and you put them in this equation. For this one, we'd have 1 times x, which is 2, plus 2 times the y, which is 3, makes a total of, they'd make $5 profit. Now, I know you're thinking, okay, companies can't survive on like $5 profit. Remember, this might be in millions. You know what I'm saying? And they make a lot of bagels. They don't just like make 6 packs of bagels. Okay? So maybe this whole thing is in thousands per day, or maybe it's in millions. All right. 7, 3. Would you please put that into the little equation? and tell me what profit you get there. And lastly, put in 2 comma 6.6. I'm going to pause for a second while you optimize this. And basically what we're doing is trying to figure out which one has the most profit. Do you have a question first before I pause? Okay, my bad. Thank you. 3 times 2 is 6. That should be 8. Sorry about that. There we go. It's 8. Did you agree? It's 8? Okay, thank you. All right, I'm going to pause. We finish up the last 2 spots. Okay. As you put in 1 and a 2 and a 1 and a 2, because that's in your equation, then you put in the points 7 and 3 and 2 and 6.6. Final answer should have been 13 for this scenario. And this last one, 2 times 6.6 is 12. 13.2. Did you get 15.2? Anybody verify the 15.2? Okay, good. That one made us the most profit. That is a typical test question. That's why there's very few questions on your next test, because it takes so long to get it from beginning to end. What do you have to do? You have to write equations. You have to graph the equations. You got to find the little corners where those 2 lines cross. You got to write this profit equation. They got to tell you how much profit you're going to make, and that's a totally separate equation. It's called the optimizing equation. And then you have to take your 3 corners, or 4 corners sometimes, stick them all into that equation and figure out which of them gives you the most profit. Is it always about the most profit? Nope. Sometimes it's about minimizing costs. I'll give you that example for education. Do you get an education? We can't really, realistically, we're not going to make a profit here at the school, but we could minimize our costs, like try to keep the costs down to keep the taxpayers from having to pay too much kind of thing. So in a business, usually all about profits. In education, we can't really make a profit here at the school, but we can at least keep our costs down. So sometimes it's about which of these has the least cost. If this had been about cost, we'd be like, hey, that's our best option because it's the cheapest one. Okay, so the vertices, the corners, will optimize your optimization equation. And I already did all of this with you, but I just want to show you another scenario right here. Here was our little corner where they all crossed. That's got 3 different spots, which all could be our best case scenario. And here, looks like we're trying to selling gasoline and fuel oil. And so this is, again, costs. And our optimization equation would be based on what they tell us. We'd figure out which of the corners optimizes the situation, which is always the most profit or the lowest costs. Okay? All right, let's look at your homework together. I'm going to pause for a second while we pull up the homework. Okay, so here's the worksheet. And our optimization equation is, by the way, that's totally different than these. You don't graph your optimization equation. That's the thing that tells you like how much profit you get. All right. So let's actually assume for a moment, hey, cool, this is really nice. They told us where those crossed. We don't have to solve on this one. That's not what this first one's about. All right, let's go look at number 2. So here we've got plant A and plant B. Okay, so the first thing you've got to do is decide about what you're making. It isn't labeled down here. I don't know yet whether we are making, like, well, I guess I can look in the problem here. We are making toy dump trucks and toy fire engines. All right, you guys get to pick, but I strongly recommend that you take whatever they tell you first and make that your X. Okay, now unless we've already got it decided for us because it's already been graphed, I think we do actually. So then, this is a little bit of a flaw in the worksheet. Sorry about that. It doesn't tell us which one's X and which one's Y. So let's figure it out. Can anybody figure out from the equations they've given us which one X and which one Y has to be? One of them is dump trucks, one of them is fire engines. Let's pause for a second when we figure that out. All right. This is something we should have told you, but X is the hours it takes to make, was it dump trucks on X? Was X dump trucks? Okay. Dump trucks. Now that we've got that, we can do this problem. And this one was hours to make fire engine. Now, the variables. That's the first thing we just defined right there. What we just said. X was hours to make dump trucks. Y is hours to make a fire engine. Constraints. The little area of the worksheet that says constraints, that's where you're going to write your equations. Those equations come from these little statements up in here. And last, the optimization equation. We want to minimize our costs. That was the costs right here. It costs 30 per hour to make the dump trucks and 35 to make the fire engines. I know we're done very soon here. Sit down, please. And we are going to write the optimization equation, which will have the 35 and the 30 in it. That goes here. All right. That's all I have for you for today. Tough lesson. It's the best I can do for you in this 1 hour.